right, so for this question, you have to find the structures that are enantiomer with the one that you are given above. So, do you know how to find enantiomers, or do you know what an enantiomer is?
It's the mirror of it.
Yeah, it's basically the mirror image of it. So, there is two ways that we can go over this question. You can rotate those molecules and see if you are able to get the mirror image of it, or you can determine the RS configuration of each and see if it is the same or the opposite. And if it is the opposite, it will be enantiomer, and if it's not, it's this. If they are the same, it means it's the same molecule. So, for example, here on the original one, I noticed that I have one chiral center, which is this one. This one cannot be a chiral center because it has two metal groups on it.
You said two methyl.
Yeah, this is a metal group, and this is another metal group. But this one, I will highlight it. This one has just one metal group, and it has three different carbons, so I can define their priorities. So the one at the bottom is more, it has more branches. So this side is more branched than the side above. So that makes this side the first priority. That makes it number one. And on the other side, we have also a carbon chain, just like we have it here. But on this side, I do not have any substitutions. So that makes it less prioritized. So it will go at the second place. And this metal group will come next because it's just one carbon. And there's supposed to be an invisible hydrogen, which is hidden here. They didn't show it because it's a skeletal structure, but it's here. And hydrogens are always considered as the last one, so it's number four. Uh, Let me know if it makes sense so far.
Yeah.
All right, cool. So, mm, so based on how one, two, three are going, so one, two, three is going clockwise. It's going like this. So when it goes clockwise and the hydrogen is behind, so the hydrogen is dashed, that would be R. So remember that clockwise is R. That's the rule. And if it were anti-clockwise or counterclockwise, it would be S. And so we have to do the same for the other ones. But some of them have different shape than the original one. For example, molecule 4. You see that the metal group is closer to this, which is not the same as this one. So this one can never be enantiomer. Same thing for molecule 3. So I can rule out those two. Then I have molecule 1, molecule 2, 5, and 6. So those could be enantiomers. I just have to check if they are S. So if they have S configuration, they would be enantiomer. But if they have R, it will be just the same molecule. So I will start with molecule 1. So the first priority, it's the carbon which is the closest to this. So that would be 1, and the other side would be 2. The methyl group would be 3. And 1, 2, 3 is going counterclockwise this time. So when it is counterclockwise, it's S.
Yes. Right.
Right, so that's S. So this could be an enantiomer. Mm, The second one, we have 1, 2, 3. So that's
Clock.
also counterclockwise, but the difference is that we have dashes. So, which means that the hydrogen is wedged. And if the hydrogen is wedged, it means that you have to flip the configuration. So, for example, here, since we got counterclockwise, oh, sorry, this is clockwise, my bad.
Right.
Yeah, so for example, here we have clockwise, so it's supposed to be R, but I have to make it S because the hydrogen is wedged.
Right.
Alright, so this one is S, just like molecule 1, so that could be an enantiomer. And for molecule 5, uh, we have 1, 2, 3, so that's also, oh, that's clockwise,
Clock.
so that's R. So this is the exact same as the original one, so it's not an enantiomer. And molecule 6 is 1, 2, 3. It's counterclockwise, but since I have dash here and the hydrogen is on the wedge, so I have to flip it and make it R. And R is the same as the original one, so that's not an enantiomer. So the only ones that enantiomer is molecule 1 and 2.
Okay, I just put that answer and it says correct.
All right, cool.
I have another one. Hold on, let me get the picture.